Now I'd like to discuss creating different pattern types. So if we click on this pattern creation button, you see that you have a couple of different icons. This one is for creating grids of spots. This selection is for continuous rastering, and then this one is for separated rastered lines. So I'm going to start with creating a grid of spots. So what I'll do is I'm going to place a spot in the upper left, and I'm going to then place a spot in the lower right. And what this does is this orients the data collection to start from upper left and work towards lower right. So now you can see that this is default set up for 2 by 2, so 2 rows, 2 columns, the tooltips tell us. So I'm going to make this 3 by 3. And when I hit enter, now we have a grid of 9 spots. And you can see that it's kind of hard to see these. So what I'm going to do is I'm going to go up here to File and Axiom Properties, and I'm going to increase the pixel size of these grids. So I'm going to make it about 14. Let's click OK. That makes them a lot more visible. Actually, this one's kind of on a white spot. So, and now what I can do is I can go down here to manually adjust the parameters. And what I would like to do is I'm going to make these about zero point 0.4 and 0.4 spacing between locations. Okay, so now we have a total of 0.8 millimeters horizontal, 0.8 millimeters vertical, 0.4 distance between each location. All right, and so now I will click into the field here where it says 1, and now we see that we have the experimental settings, and each location is represented here. So if I drop down on the CCD spectrometer, you can see this is where you can control the gate delay. And also you can choose to accumulate the spectra by checking this box, or by unchecking this box, you would have a spectrum created for each shot that was fired. So in this case, if I fire 10 shots, which is the number of shots default set here, and under non-accumulated conditions, I would get 10 spectra. And if I fire 10 shots with a checkbox accumulated, what it will do is additively accumulate all 10 of those spectra and make one spectrum to be saved and worked with in the data analysis software. Also, we have now spot sizes to choose from. So for this, I'm going to do a 100 micron spot. So I'm going to up my energy to 60%. And also in here, you have gas flow settings. Helium, argon, you can switch the gases. So it's plumb to run either one through either gas 1 or gas 2. Okay. And here's where you set your gas flows. And actually, we have to go to the gas panel to turn the gas on. So if I select 0.5, whoops, for helium and hit apply, you can see down here that the real-time gas flow has updated. Now it's flowing 0.5. A couple of other things that I'll point out about the gas panel. This is flow 1, flow 2, flow 3 is for double volume cell, which this instrument is not equipped with. But you can also change which gas flows through the chamber. So in this case, helium has been selected to flow through the chamber, or flow 1, flow 2. Would then, if I selected flow 2, what it will do is put argon through the chamber. So now I'm going to turn this gas off because we don't really need it, and hit apply, and then you'll see it'll update here, and this will go to 0. In the meantime, this was in bypass mode. If you want the gas to go through the chamber, you click online. Now back to the pattern creation. So I created this pattern, okay, and what I'm going to do is not fire 10 shots, I'm going to fire 25 shots at 60% energy, and I'm going to collect them in a non-accumulated fashion. Now, the important thing about setting your pattern up to move from upper left to bottom right is that's the way our data analysis software is set up to parse the data for 3D mapping. So it's important to set your pattern up so that it's going top to bottom, left to right. Over here, you can see this arrow. So pattern direction, right click for snake option. So first thing, let's go ahead down here, turn on grid numbering. So if I turn on the grid numbering, you see that this is 1, 2, 3, 4, 5, 6. So this is set up to go in a snake path, okay? Now, if I change this to go horizontal, now what we see is we get across the top, 1, 2, 3, drop down, 4, 5, 6, in the snake pattern. I'm gonna set it up to go vertically, and then if you wanted it to not go in the snake pattern, you could right click on this and then hit this checkbox, and then you see it's unchecked now. But I'm going to check it because I want to use this data to create a 3D map. So I'm going to go ahead and check. So now check the snake pattern, and I have it oriented to go in the vertical direction. Okay, and I'm going to go ahead and hit fire now. And what we can do is we can view real-time spectra while the data is being collected. Down at the bottom, you'll see there's a shot counter. So this is how many shots that the spectra, or how many spectra are being, so it counts the number of shots that the laser's firing and that the spectrometer is actually detecting. So in each case, it should count up to 25 because that's how many shots we set it up to fire. And so for each location, 25 shots are being, 25 spectra are being created. So now the data collection has completed, and what I'm going to do is save this as, and what I'm going to do is just I'm going to give it a name that's pretty specific. So I'll call it, this is NIST 610. You can see that it has a default naming scheme. So if I save the pattern, which I'm going to save a pattern, and we'll see this on the next run, but it's date and time stamped. So it'll have the actual pattern name. So you see it has this one, which is the default name here. If I created another pattern, that would be default number 2. But in this case, I'm going to call this NIST 610 3 by 3 25 non-accumulated shots 0 1. Okay. So now I'm going to go ahead and save this pattern. So I'm going to click up here and right click now and say save experiment. So it'll open the dialog box, and so you'll notice that this goes into the same folder where I saved my macro image at the beginning. So what I'm going to call this now is I'm just going to call this NIST glass 3 by 3. Now you see that this is turned blue. Okay. So if we had multiple patterns in here, the blue pattern would be the one that would not be, you would not be editing it. So if I highlight this, you'll notice it turns back to light blue. Light blue is the default for the edit pattern. So if I changed any parameters, it would be on the pattern that was highlighted in blue. So let me go ahead, and what I'm going to do is I'm going to go ahead and collect data for the NIST 612 sample using this same pattern. So I'll go to the macro imaging, and I'm going to click on an area of the NIST 612, and then I'm going to go ahead and It looks like it's in focus, so I'm going to leave it like that. So now what I can do is I can choose this move pattern icon and move the pattern right to here. So now it's set to go on NIST 612. So I'm going to go ahead and fire this again. And now that this one's complete, I will go ahead and move to the NIST 614 sample. You can see this one's a little bit out of focus, so I'm going to try and use the autofocus, and that worked pretty well. Brought it right into focus, and now I'm going to turn the displacement sensor laser off, which I should have done to begin with, but that's okay. So now I'm going to go ahead and move the pattern over here, so you'll see that now it updates the focus. You'll see the Z position is now the same as the actual stage position. So as I move the pattern, the focus gets updated. And now I'm going to go ahead and fire this and collect this data too. And now that this one's complete, what I'll do is I'm going to go ahead and save this data. So I'm going to right click and save selected as. You can highlight all of them together if you'd like. Um, Either way is fine, but what I'm going to do is I'm just going to change this to NIST 612. Okay. NIST 614. Okay.